This is Geometry Lesson 2-2, Conditional Statements. Our topic is our objectives are to recognize conditional statements and their parts and to write converses, inverses, and contrapositives of conditionals. I promise by the time the lesson's done today, you will know what all those words mean. So let's begin. Okay, so our first thing is to talk about what is a conditional statement. A conditional statement is an if-then statement. Okay, you have the hypothesis, that is the part following if. So and then the conclusion is the part following then. We refer to them in our geometry notation. The hypothesis is P and the conclusion is Q. And so in symbols, you're saying if the way you would write a conditional if-then statement is you put P arrow Q. That reads as if P then Q, or P implies Q. Now we do have to recognize this as a Venn diagram. They're saying in the set of Q, there exists this P, and so if this P thing is true, because it's a subset of this entire other thing, then the other thing must also be true. So here are some examples for you of that. If you attend your Elk River High School, then you are in high school. So in the whole pool of high schools, your conclusion, Elk River High School is one of them. And so if you are in Elk River High School, that means that you go to high school. If you are in Mrs. Gosha's class, then you are in geometry. Okay, so these are some conditional statements. So one thing we have to be able to do is identify the hypothesis and the conclusion. Remember, the hypothesis is P and the conclusion is Q. So it says, what are the hypothesis and the conclusion of the conditional? If an animal is a robin, then the animal is a bird. Okay, so hypothesis is the if part. That would be an animal is a robin. And so specifically what we're talking about are robins. So we're not going to write the entire thing. We're going to write the part of it. Since the animal is in both of those, then the robin is actually the hypothesis. So if you are a robin, then you are also the conclusion, a bird. Robins are a subset of birds. So here it says, what are the hypothesis and the conclusion of the conditional? So remember, your hypothesis is P and your conclusion is Q. Your hypothesis comes after the if and your conclusion comes after the then. So pause the video now and see if you can identify those. Okay, so my hypothesis is that something measures 130 degrees and my conclusion is that it is obtuse. Let's move on. Okay, so now we have to be able to write a conditional. It says, how can you write the following statement as a conditional? Vertical angles share a vertex. So we need to identify what is the hypothesis and what is the conclusion to start with. And so you want to think about what classification up there is larger, has a larger number of options in it. Are there more angles that are vertical angles or more angles that share a vertex? So I might draw a picture for this. Here you have two lines. These green ones are vertical angles, but in that picture, there's actually 4 angles that share that vertex. So you can kind of see that, oh, vertex is the bigger. Angles that share a vertex, that's the bigger set. So that's actually going to be your conclusion. Angles share a vertex. So the smaller set is going to be that you have vertical angles. So once you have that identified, you're ready to actually write it. So you start with if, and then you could say vertical angles are really a pair. So if a pair of angles are vertical angles, if a pair of angles are vertical angles, and that's your hypothesis. So after your hypothesis, then you get to your then you could say, comma, then they share, and then actually let's be more specific. Let's say the angles again. Then the angles share a vertex. All right, and so what I want you guys to do is try this next one. It says, how can you write dolphins are mammals as a conditional? Remember, think about what's the bigger set, what's the smaller set. The bigger one is your conclusion, the smaller one is your hypothesis. All right, check your answers with mine. I said the hypothesis is dolphins, and the conclusion is mammals. So you're not going to say if dolphin, then mammal. You want to be a little bit more grammatically correct than that. So you might say if an animal is a dolphin, then it is a mammal. Or you could say if an animal is a dolphin, then the animal is a mammal. Okay, so that's writing conditional statements, if-then statements. And so the one thing about conditional statements is that they have a true or false value. They're true or false, and so we call this their truth value. All right, let's just delete that. There we go. The true or falsivity of a conditional. And so that, like I said, they're either true or false. To show that a conditional is true, you must show that it's true for every single case, meaning every single possibility. To show that a conditional is false, you only need to show one counterexample. One time when the hypothesis is true, but the conclusion is false. So here's an example. If you were at a Burger King, you are in Illinois. Now, I don't know about you, but I'm pretty sure I've been to Burger Kings that are not in Illinois, such as the one just down the road from here. That would be a counter example of this. You were at a Burger King, however, you were not in Illinois. Okay, so finding the true value of a conditional. We're going to decide if each conditional is true or false, and if it is false, we have to find a counterexample. So it says, if a woman is Hungarian, then she is European. So if we're looking at this map, you can see in Hungary is in red. And if you look, this map is labeled Europe. Here's Hungary. Is Hungary one of the countries in Europe? Yes. This is true. Okay, that's our first example. Here's some more. It says if a number is divisible by 3, then it is odd. If a month has 28 days, then it is February. If two angles form a linear pair, then they are supplementary. What I want you to do is see if you can come up with a counterexample for each one of these. So pause the video and see if you can find a counterexample, then it's false. But if you can't, then say that it's true. All right, for the first one, number 2, so I would say false. 6, 12, 18, 24, 30. Those are all examples of numbers that are divisible by 3 and even. Number 3 is kind of a tricky question because every single month has 28 days. If it's if a month only has 28 days, then it is February. That would be a true statement. However, every single month of the year has 28 days. And then number 4, if two angles form a linear pair, then they are supplementary. That is true by definition of a linear pair. Okay. So the negation of a statement P is the opposite of that statement. And when we negate a statement, we see this little squiggly line in front of it. You're saying not P or not it. And so here we're going to negate some statements. It says the sky is blue. The negation of that would be the sky is not blue. And notice I didn't just change it to the sky is purple, the sky is green. I just said the sky is not blue. That's the opposite of being blue is not being blue. And so when we create those negations, we just, we're not going to get into specifics. We're just whatever the opposite is. The grass is green. The grass is not green. Mrs. Gosha likes football. Mrs. Gosha does not like football. So those are all negations. They're the opposite. Okay, now the reason why we use these negations is because of these next concepts we're going to talk about. We've talked about the conditional statement, if, then. Notice that that form is P arrow Q, the hypothesis and the conclusion. When you have a conditional statement, you can actually create 3 more statements from that. So the first one is the converse. What the converse does, and no, this isn't like your shoes, is it takes the hypothesis and the conclusion of the conditional and it flips them. And so it becomes, so if our example for our conditional is if the measure of angle A is 15, then angle A is acute. For converse, that will become if angle A is acute, then the measure of angle A is 15 degrees. It becomes Q arrow P. It switches the order around. Now, the inverse negates the conditional. It goes all the way back to the conditional and it's the not. Converse switches. This is how I remember all these. I think I spelled switches wrong. There you go. It says, if the measure of angle A is not 15, then A is not acute. It's not P implies not Q. Now, the contrapositive, it does everything. It switches and negates. And so it says, if angle A is not acute, then the measure of angle A is not 15. Not Q implies not P. So you have your conditional, if P, then Q. Your converse just goes, hey, let's switch that around. If Q, then P, And your inverse says, hey, let's go all the way back to the conditional and just negate everything. Not P means not Q, and the contrapositive switches and negates. It does it all. This is great note card material, by the way. So the truth value of these statements are related. When statements have the same truth value, they are called equivalent statements. Now, our equivalent statements, well, let's look at these. It says, if we start with our conditional, that if the measure of angle A is 15, then angle A is acute. Is that a true statement? To be acute, you have to be between 0 and 90 degrees. It is. Hey, that's true. The converse says if angle A is acute, then the measure of angle A is 15. Well, I have a few counterexamples for you. How about angle A is 27? How about angle A is 13? Those are all counterexamples which show you that that is a false statement. The next one says if the measure of angle A is not 15, then angle A is not acute. Well, if the measure of angle A is 27, that's not 15, but that is still acute. That is a false statement. The contrapositive then says if angle A is not acute, then the measure of angle A is not 15. Well, that is a true statement. Now, notice the color coding it has up here. Conditional and contrapositive have the same value. The converse and the inverse have the same value. When I'm talking about value, I'm talking about the true or false value. If the conditional is true, so is the contrapositive. If the converse is true, so is the inverse. There are times when all four of these are true, and there are times when all four of them are false. Now, those are special cases. Okay, so let's practice writing some of these and finding their truth values. This is our last slide of notes today. It says, state the conditional, converse, inverse, and contrapositive of each statement below, then determine the truth value. So let's start with this. Squares are quadrilaterals. The first thing we have to do is write this as a conditional, an if-then statement. So what's the broader category? Squares are quadrilaterals. Well, quadrilaterals include trapezoids, rectangles, and things like that. So this is bigger, meaning it is your conclusion, meaning squares are your hypothesis. So we could say if a shape is a square, then it is a quadrilateral. This is our conditional. From our conditional, now we're going to come to our converse. Now our converse switches the order. It says Q arrow P. So we're going to say if a shape is a quadrilateral, and I'm going to abbreviate quadrilateral as quad, then it is a square. And notice we're not even worrying about the true and false values right now. Remember, the inverse now says not P means not Q. So we're going to go back to the conditional. If a shape is a square, then it is a quadrilateral. We're just going to negate it. If a shape is not a square, then it is not a quadrilateral. And now for our last one, the contrapositive, it does it all. It flips and it negates. So we're going to look at that. If a shape is a square, then it is a quadrilateral. We're going to flip it. If a shape is a quadrilateral, then it is a square. And then we're also going to negate it. So we're going to say if a shape is not a quad, then it is not a square. Now that we have our statements, we have to come up with our true or false values. So if a shape is a square, then it is a quadrilateral. Well, quadrilateral means something is a four-sided figure. Does a square have four sides? Yep, that's a true statement. I'm going to put a big T next to it, another color. You've got some space on the left or the right of that to write that as well. If a shape is a quad, then it is a square. That's saying any four-sided figure is a square. Can you come up with a four-sided figure that's not a square? How about a trapezoid? How about a rectangle? Those aren't squares. That is a false statement. Now, I don't have to actually read the rest of the statements knowing those top two. If I know those top two, I know the next two. Because the conditional, our first statement, is linked with our contrapositive in here, which is our last statement. They have the same value. So the conditional is true, which means the contrapositive is also true. The converse and the inverse also have the same value. So if the converse is false, the inverse is also false. Now, you have a question to do on your own. It says the vegetable carrot contains beta carotene. What I want you guys to start with is writing your conditional, your converse, your inverse, and your contrapositives. So pause the video now, write those, and then we'll discuss the true and false values. Okay, here's my statements. My conditional is if a veggie is a carrot, then it contains beta carotene. My converse is if a veggie contains beta carotene, then it is a carrot. My inverse is if a veggie is not a carrot, then it does not contain beta carotene. And my contrapositive, my last statement, is if a veggie does not contain beta carotene, then it is not a carrot. So what we have to come up with now is decide if these are true or false. So here's where Google might come in handy in this specific example, because I don't know about you, but science is not necessarily my forte all the time. So let's look it up. Do carrots have beta carotene? Look it up on your phone, see if you can figure it out before I do. Carrots, beta carotene. My internet is slow today. According to Google, it has 4,142 micrograms of beta carotene. Awesome, that's true. So then the next question, if the conditional is true, what else is true? Think about it. The contrapositive, our last one. Now we have to decide, do other vegetables that contain beta carotene? So let's Google it. Beta carotene in veggies. I don't know about you, but it looks like sweet potatoes, broccoli, might have it. Aha, yes. According to Google, green leafy vegetables such as spinach, Swiss chard, turnip greens, and beet greens are very rich sources of beta carotene. Well, if a veggie contains beta carotene, then it is a carrot. Spinach has beta carotene. I don't know about you, but spinach is not a carrot in my world, meaning that's false. If the converse is false, so is the inverse. There you have your true and false values. And we came up with our counterexamples together. All right, way to make it through the notes. That was lesson 2.2 of geometry. Remember, our objectives were to recognize conditional statements and their parts. So you're recognizing the hypothesis and the conclusion, to write converses, inverses, and contrapositives.